Bueno, pues vamos a continuar reflexionando sobre la experiencia internacional, en esta ocasión de la gestión de la propiedad industrial, vista desde las instituciones científicas. Para ello contamos con un ponente que también es internacional, Hubert Dols. Good morning, Han.
Morning.
It's a pleasure to have you as speaker today to present the CERN experience in the field of industrial property rights. I'm going to introduce you, and after that, I leave you the floor.
Perfect, thank you.
Han Dols is leading the business development section at CERN with responsibility for building industrial and strategic partnership and innovation alliance in the 23 CERN member states. Aim is to accelerate innovation at multinationals and startups by leveraging the wide range of CERN technologies, including data science and artificial intelligence. He has been driving innovation in various roles and industries and has a background in physics, business development, and marketing strategy. In addition, he is certified as Artificial Intelligence Business Advisor. Prior to joining CERN, has worked for 15 years at DSM, a global life science and material science leader. At DSM, he leads strategic marketing planning for various industrial segments like automotive, electronics, and industrial coatings. Before that, he was a part of the DSM Innovation Center, with responsibility for global business development of the world's strongest fiber in medical application like hair valves, covered stent, and orthopedic devices. Han also created and executed a strategy for bringing a portfolio of regenerative medical materials to market in Europe and Asia. Please, Han, when you want, you can start to share your screen and explain us your experience about the property right management.
Yes, thank you very much for that nice introduction. So it's a pleasure for me to share with you some of my experience in the field of intellectual property and how that relates to business development and innovation. For those who have listened a bit to the introduction, so I don't have an IP, let's say, background by studies. I'm an engineer. In fact, I studied physics in the Technical University in the Netherlands. And after that, my career went quickly in the direction of business. So I've been working in the industry for more than 25 years, where I have been very closely working with legal advisors and IP lawyers whenever we had specific cases that need to be tackled. So what I want to do now in the next 30 minutes is to give you, first of all, an impression of how CERN is looking at IP from a perspective of, let's say, bringing our technologies to other applications in markets, and also from a kind of, let's say, sort of a pragmatic perspective from the experience that we see. So what I write here, accelerating innovation, it's kind of interesting because most people associate CERN with accelerating particles, right? I guess you all know that we accelerate particles to extreme energies in order to collide them and find answers about fundamental questions about physics. So this is very much a fundamental science activity. And I think much more fundamental science than what you often see in universities. Universities often have more, let's say, already more applied research activities, where it's a bit more easier sometimes to build a bridge to an industrial application. At CERN, we really want to find Higgs bosons and very small particles that you can hardly imagine. So that is really good to have that as a starting point. It's very fundamental that we do that. However, the role that I lead at CERN is to see how can we use that technology that we develop in other applications, other industrial applications. So we want to accelerate innovation, if you will. So just to show this quickly, because it's interesting, when CERN was founded actually right after the Second World War, it was already clear that one of the missions was to share know-how, so to share intellectual property in an open way, so society could benefit from all the learnings and all the inventions that would be made along the way in this physics ambition. And that is also what happened. So here you see one of our let's say tunnels, where you see this large hadron collider. It's a huge tunnel, 27 kilometers long, 100 meters under the ground. And what you see here in this metal tube is kind of interesting because, first of all, the temperature is about similar to that in space. It's extreme vacuum, there's radiation, there is extreme strong magnets in there, therefore you need superconductivity. So this is filled with a lot of technology. So one component of all this IP that we have, of all this intellectual property, relates to hardware, the hardware that you need to accelerate particles. Then there is the let's say the detectors that there are. So here you see Lake Geneva on the top corner, and here you see how this ring, this accelerator ring, is positioned under the, let's say, ground close to Geneva. And you see here 4 places where cameras are installed, if you will. And these are not cameras like your photo camera. These are huge instruments that have the size of a cathedral, so to speak. And also these detectors have a lot of sensors and chips in it that you can also apply in other applications. And then lastly, the component is everything that relates to digital. So what you see here is a picture that is derived from one of the collisions of particles with each other. So as you can imagine, it's not just one particle colliding with one particle, it's millions of particles that collide kind of at the same time. And that generates a lot of data. It generates 25 terabytes per second. So that is really a lot of data. So we need to have the know-how to store the data, to manage the data, to analyze it, to use advanced statistic techniques to understand what we see, to use machine learning. And the interesting thing here is all this know-how, again, can be applied on other domains. So yes, we have been working a lot with huge data files already a long time ago, even before the word big data was invented, so to speak. So that is another, let's say, component of the intellectual property that we have. So in a nutshell, my message as a starter of this presentation is that we are sitting on a sort of a pile of technology that you see here that relates to sensors, robotics, metrology, magnets, vacuum. And the role that we play at CERN in the team where I'm working is to see how can we find new applications for this IP in, for example, medical fields, in automotive, in totally different sectors. And that is very close to what CERN wants to achieve. Of course, we are there to do fundamental physics, but yes, we also want to help industry and institutes in the member states that support CERN to drive their own innovation. So this is a bit the context. So here you see basically that at the core we have all the IP relates to accelerators, detectors, and computing, and somehow that finds its way into different domains: medical, aerospace, cultural heritage, better planet, etc. So to give you a better feel for that, so in the medical domain, there are accelerators, just like you see here on the bottom. There is a sort of accelerator ring that also accelerates protons, and these are used to treat cancer patients. So as we speak, there are centers in the world that use accelerator technology very similar to CERN. So they use the same know-how and the same hardware as we have to treat patients. And also in the imaging domain, I'll give you one example. So some of the sensors that we use in CERN are very good to detect, let's say, single photons in a very precise way. So we can measure even the energy of one photon precisely. And that technique can be used also to make very advanced X-ray equipment. So these are examples where you see that CERN technology found its way to applications in the medical field. And of course, this is supported by contracts that govern a license or that constitute a sort of a collaborative R&D, which I'll talk about later. Then also in space, so why is there so much overlap between what we do at CERN, 100 meters under the ground, and what's happening many kilometers above the ground? That is because in CERN, in the institute, we have the conditions that we work with and where we test our materials and equipment is very similar to space, because the temperature is also very cryogenic. So you're talking about a few Kelvin, it's extreme vacuum, there is radiation. So the harsh conditions that we see inside the LHC tunnel mimic the space situation. And therefore, when companies or institutes want to test electronics before it goes into space, or want to test how radiation tolerant specific instrumentation is, at CERN we can really help those. So from a knowledge transfer perspective, we use different instruments to make this happen. So of course we do networking in the member states, we have entrepreneurship activities, so we allow people at CERN to create a company based on CERN technology, so these then get a license on a specific piece of technology, hardware or software. We organize events. Of course, we have intellectual property management. We have a team working on that, which I work very closely with, where we help to set up R&D collaborations, where we manage our patent portfolio, where we have license agreements. And yeah, of course, we also have a strong open source policy. It's also interesting to mention here that it says open source software, but also open hardware license. So CERN has been working to make an open hardware license that has the same principle as software. So of course you want to share hardware, but whenever somebody makes an improvement, you also would like that this improvement is shared again with the community. So under this open hardware license, we also give access to specific hardware elements that we have developed at CERN. So how do we now manage all this from an IP perspective? And as I said, I'm not an IP lawyer, but I will give you sort of a practical feel of how it works at CERN, and I hope that is interesting for you. So basically, we have a couple of policies in place that govern how we do knowledge transfer and that explain all the IP aspects that are related for that. So first, there is sort of a high-level intellectual IP policy. There's a policy on the management of intellectual property in the technical transfer activities at CERN. So to give you a little bit of flavor, what is written in this policy? First and foremost, it's explained that the policy is there not to protect, let's say, the know-how and keep it for ourselves. No, the intention of this IP policy is to maximize the dissemination and visibility of technology. So often when you work, I worked in industry, I mentioned a couple of times before, and sometimes in a company, your IP strategy can be either to protect your technology from competition, or on some other IP policies you might see in companies that you have a sort of more open innovation approach. But at CERN, really the overarching goal with our IP policy is to help that technologies at CERN find new applications outside CERN. That is a very important starting point. So that's also why we really, of course, want to make sure that it's compatible with collaborative and open research. It's also clear that we do express here that priority is given to CERN's scientific program. And what we mean with that is it would be very weird if we would give a license of technology to a startup that comes out of CERN, and somehow that startup would file a patent on something which would block our own research. That would be very weird, right? So of course we need to also make sure that our scientific program always has the priority and the freedom to excel. Then another interesting thing is that, remember that CERN is an intergovernmental organization. So we are not from one country. We are from 23 countries, including Spain, by the way. So we need to make sure that all these member states have equal opportunities to get access to IP, that industry and these companies have equal opportunities. And also we want to actually give preference to those member states over other member states. And then the last two things, maybe the last one is obvious. So CERN really wants to stay far away from anything that has to do with military or defense applications, and no competition with industry. That's also maybe good to explain. If you think about your IP management, you don't want to get in a situation where we as CERN would start to compete with a local Spanish research institute, for example, right? So you don't want to organize it such that this element of competition arises, because for us, CERN we're not a commercial entity. We're not a commercial entity. We want to focus on science. And the results from that, we want to disseminate as good as possible. So that basically this, let's say, this thought is really well captured in the IP policy. So, and then also it's outlined there, and I listened into some of the earlier presentations, and although I don't understand Spanish, I got a little bit of it. We also have a sort of a couple of standard approaches that we use. So I'll talk you through this. So in some cases, we have an existing technology. It can be a tangible piece of electronics, for example, or a piece of hardware that we have developed, where we are the owner of it and where we want to give somebody access to it. So then we make a license. We give a license agreement so somebody can use that. And of course, like in any license agreement, you try to think about what is then the field that it can use this in, for how long is the license running, is it exclusive or is it non-exclusive? Typically at CERN, we prefer non-exclusive agreements because the IP policy says we want to disseminate to everybody, right? So the license is also covering some software that we have. So we have a lot of license agreements in place at CERN for hardware and software. Then there is consultancy for services. Sometimes a company just wants to get a sort of a second opinion or wants to have an idea about some technology that they have, and they can use our know-how. So they can use some of our, let's say, insights to challenge their own ideas. So that is more consultancy. So we have consultancy contracts. Then we have contract research, where you really see that it's something that we can build for other company. We don't do this a lot, but in some cases it's so close to what we are doing already that we support contract research, and we see a lot of collaborative R&D. And why do we see a lot of collaborative R&D at CERN? Because we don't make products that a company can directly use or directly sell, so to speak. Why we remember that we are this fundamental research organization. So everything that we make has a relatively low TRL level, technology readiness level, from a commercialization point of view. So it means that typically a lot of energy is needed to develop this to the next level. And therefore you don't want to just throw this technology over the wall and say, have fun. No, you really want to hold their hands and work together to learn and improve this. So, and in this collaborative R&D agreement, there you see the typical IP clauses, like everybody has its own background IP. The IP that is created belongs to there where the work is done. If this is unclear, then the IP is shared. So very typical things that you also see in the European Horizon frameworks, for example. So those 4 contracts we typically use as a starting point, but in practice, I have to say, often we tailor them to the specific situation, because many times the situation needs fine-tuning to make the most suitable situation for both a company or institute and CERN. So another policy that we have that is basically below the IP policy, so that details a bit further some specific elements, is this our software dissemination policy. And I think the whole field of software and IP is, I would say, pretty complex, because often you have situations where a bright mind at CERN starts to program something, and then in order to do that, he talks to some colleagues who work at different universities, and then he uses different components from the internet. So in the end, you have then this piece of software, but you really have to ask yourself the question, wait a second, what is this software made of? Which components did you use? Where did you get them? What kind of license was that provided to CERN? And also, who did you involve to develop your software? Is it really only coming from your own brain, or were you working with other institutes? So, and that is often a very, let's say, doing this due diligence is really important. So our software dissemination policy basically describes these 4 cases, where you see here on one hand, you see external code components. Are the external code components used? And here is, are there any external non-CERN contributors involved? And very often you're talking about a situation where there is a lot of uncertainty, because there are multiple components being used from third parties, and there are multiple people involved. On the other hand, case number one, of course, is the most easy. If somebody says, listen, I made this software, I made it all by myself, and I didn't use anything from anybody, then it's very simple to conclude, okay, so then it's CERN proprietary, and then we have all the dissemination options available. We can make it open source, we can do whatever we want. So I wanted to just share this with you, that we use this approach to, let's say, structure our software policy. Then another policy that is below the IP policy is our patent policy. So that goes a bit more specific into how we deal with patents, when we file patents, how we maintain the patents, etc. So that policy, I took a few things out of there. So, so the first thing it says is patent protection serves as a tool for knowledge transfer. So that is really important to say, because remember that what was written in the IP policy, in the end, what we want to do as CERN is to make sure that as many players as possible use CERN technology to do something good for the world, if you will, right? We want that other people can leverage our know-how to do something. So in many cases, we choose to go open source. Now, in some cases, we think it's better to file a patent because it might help industry to advance. So I'll give you an example. Imagine that you have worked on a laser technology that you could possibly use in a LiDAR technology for a self-driving car, right? And we have developed that laser technology. Before you have really brought such a technology to the market and have tested it and have got all the regulations, you need to invest as a company millions to make that work. So in some cases, we say, well, wait a second, if we file a patent on this technology, it will be more interesting for a company in the end to work with this technology, because then they will be able to protect the technology. So we do file patents, not with the intention typically to stop others, but we want to file patents if it helps us to disseminate the technology. So we do file patents only when we think it will make it more interesting for industry to invest in the field. So that's why we don't have a lot of patents that we manage. We try to really say we have to be careful and be very critical to, is it really a strong invention that can be applied very broadly in multiple markets, and is it really something where a company is more interested if we have a patent that otherwise you would say, well, I'm not going to invest millions because otherwise the next competitor can copy paste everything. So that's really interesting to realize. So if you look to numbers, you see we have 17 patent families, around 50 patents, and we also have a bunch of trademarks. But for CERN, of course, that isn't so much. And also what is very interesting to know is that we get many experts knocking on our desk to say, hey, I have a nice invention, should we patent this? And it's very important that you understand that we also look at it from let's say from a finance perspective. We are a publicly funded organization, and we don't just want to patent in order to patent. You know, patenting itself is not the goal. The goal for us is, how can we make sure that the technology finds its ways to other applications in the most suitable route? And sometimes this is a patent, and sometimes it is not a patent. And so we also had to explain to our experts sometimes that if we say we are not going to patent it, it's not a disqualifier for the invention or the technology. Really, it's really from the angle of, is it worth the financial investment to do this, and will it help the dissemination? So, and then the last policy I want to shortly touch upon is a spin-off policy. So that relates to the CERN policy to support companies, startups that are established using the technology that we have. And that's also interesting, because there are quite some startups that use CERN technology. And all these startups, they have a license with CERN. And that license says that the startup is allowed to use this technology in a certain domain. It always says that, of course, we exclude any military application, and it regulates also in the parts of the world where they can use the technology. It regulates for how long this is done, and there is a small percentage value share that we ask from these startups. And why do we do that? Because you might argue, well, you're not a commercial entity, so why would you do that? Well, we have what we call a knowledge transfer fund, and the money that we earn from these startups, we use this to invest in new ideas at CERN that can again then be licensed to companies. So we try to create a self-fulfilling fund. So we have a little bit of money to play with to really explore applications of early stage technology into different fields. Yeah, so this whole field of startups, we have also an entrepreneurship team working on that. It's really a whole a team by itself that is supporting this. But again, the fact that we have this spin-off policy helps us to make clear to everybody what are the expectations and what are the conditions under which CERN provides these licenses. What I wanted to do now, I wanted to give a bit of examples to make it more concrete. So here you see a company that we helped with improving their vaccine production using machine learning. So in this case, it was really this consultancy approach. So we had an open source machine learning toolbox that Sanofi has learned, but in order to really get up to speed, they really needed a helping hand on how to interpret everything, how to get everything set up. So in this case, sort of a consultancy framework was the best way to make this work because the toolbox itself was open source. Here you see a place in a hospital where people can get a treatment, a proton therapy treatment against cancer. And it really is impressive because really, you won't believe it, but next to this room, there is this room. And as a patient, you're not aware. I think it's very good that you're not aware because it looks very scary, right? But what you see here is literally a circular accelerator with all the technologies that we also apply at CERN. So of course, when this was built, we had to have multiple agreements in place on how this Matt Ostrom facility could leverage from the hardware that we have, the software, the control environment, and that is all managed in a collaborative R&D agreement supported with licenses to make sure that this would work. Another example I wanted to give is on a company in Germany who actually prints euros. It's a German-owned company who prints euros, and they were really looking for how can we make passports more safe, the next generation of passports. And that's not just German passports, that's also, I guess, passports in other European countries because they do this for Europe. And the interesting thing here is that we have a lot of know-how and IP on material science, you know, little magnets, little things, little material science properties that you can use in a passport. We have ideas about data management that relate to cryptography. And here we have agreed with Bundesdruckerei that we would work together on developing next generation concepts, but that the results would be shared publicly. So that's also something that you can agree. When you want to really do something that is relevant to a broad society, you can also agree with the party that you work with, even with a company, that the results will be shared. So you create a play field that is equal for everybody. I have one question for you. So I know that I started a bit later. How much time do I still have? Because then I can tune.
Yeah, I know that it's impossible for you to stay us to the end of the session, but I have some question. I need 10 minutes for a question and 5 more maybe for your summary of your conclusion or
yes,
something
perfect.
like that. Okay.
Perfect, that's perfect. 5 more minutes, that's perfect. So let me go to the next slide. Same for Volvo. So here we have set up a collaboration of this car company who is using our machine learning to make a better assessment of what's happening on the road in a very short time. So here we really have set up a collaborative R&D program where the company pays a fellow at CERN who works at CERN on a specific topic. And we have then an agreement in place that allows Volvo to use the results, let's say, for their interest, but also that we can use the results for our interest. Because if we can improve the speed at which we do machine learning, that is good for CERN, because then we can process more data, but it's also good for them. So of course, all these agreements, that's what I mentioned in the beginning, they are all tailored because every company has their own needs, their own wants. And yes, the negotiation about IP clauses typically does take a long time, and it often is not easy to find common ground. But the CERN way of thinking is we want them to be successful in applying the technology for their interest, but we also need to protect the fact that we can also use it for our own scientific purposes. So I'll quickly skip for the sake of time, because there are a few things that I really want to bring across to you, which are the lessons learned. So there are a few lessons learned that I think are worth sharing, because when you want to create, let's say, new intellectual property from two parties who have all their background IP, we have really seen very often that in the early days, you don't know exactly in any collaborative R&D project what will come out. So, and if you don't know exactly what will come out, it's also very difficult to have a long fight about IP if it's still all a bit vague. But it really, serendipity pays off. What I mean here is if you bring companies together or entities together that have a different background and look at the same problem with different eyes, we have seen many very innovative ideas coming out of that. So by mixing, let's say, people from CERN with a physics background, with people in medical who have a biology background, we have seen very interesting results. And the same for the field of finance and automotive. So getting different people from different backgrounds together is a very good recipe to help accelerate innovation. Then you need passionate experts on both sides. Why is this important? Because it is not easy. Our technology is low TRL level. It's really deep tech. So you need people on both sides that can put their teeth in the technology and really have the stamina to find how to make the connection. Also, this sometimes when there is this intention to work together, some companies like to make a sort of a generic umbrella agreement that has all kind of IP clauses in it. But as long as you've not defined a concrete project, it's very difficult to discuss a sort of a generic approach, because you're talking, let's say, in thin air, right? So in my experience, if you have a collaboration project that is defined, very concrete, and you know exactly what you are going to do, who is contributing to what are the expected deliverables, then it's also much more easy to agree and define your IP conditions. Otherwise, it's very fluffy what you're talking about. Last thing, really, tech experts are not IP experts. Mind the gap. I give you one little example. It was really very funny. We did a training on IP at CERN for our own experts at a certain point in time. And we know IP stands for intellectual property. And then one expert came to me after the presentation and he said it took me half an hour to realize that IP is something else, but IP for him was intersection point. That's where the protons were bumping into each other in the ring that we have. So basically, these basic abbreviations sometimes have totally different perceptions for experts, tech experts. So you really have to adjust your language and take the time to explain things there. Doing due diligence on IP early on is really key. We have also seen examples where we kind of thought the IP belonged to, let's say, CERN and partly to a university, and then we did a project with a company, and then once you are in the project, you discover that there is another university involved or something happened with the IP. So doing a proper due diligence on IP early on is absolutely important in order to prevent you burn your fingers later. And negotiating IP clauses, that really is something that works best as a basis of trust. I cannot repeat it often enough. I think it's just like buying a house. There is a lot of mathematics behind it, but in the end, it also is a matter of being able to find a base of trust and say, yes, we're going to work together. So that is what I wanted to share with you from a more pragmatic angle at how we work at CERN. Thank you.
Thanks a lot, Hat. and for your very interesting presentation, including technologies that are really close to the activities of the IFIC researchers and have a huge potential to be transferred to industrial application in many different ways. I have some questions. The first one comes from our first speaker, Marta López de Rego. She asks about what strategy do you use when patenting registered trademarks in terms of territory? Do you apply for European, international, national?
Yeah, so we do that on a case-by-case basis. So, for example, when we think about what's the area where we want to file the patent for, we do also, because, you know, of course you can file everywhere, but that also is costly. So we do really look at, for some technologies, we see, okay, where do we think these technologies will be applied? The companies that are in that domain, where do they have most traction? And based on that, we take decisions. So we really do this on a case-by-case basis. And we also discuss it with the experts, because they also know where probably the companies or the institutes are that might have an interest into the technology. So we don't spend too much money on filing patents around the globe that in the end doesn't bring anything, because, as you know, the further you go in this whole patenting process, the more these costs go up. So we try to be careful with that, and we do it on a case-by-case basis.
Okay. I have other question that come from Fernando Hueso González. It's concerning about the open software and hardware from his personal experience. Small or middle-sized research centers don't know foster or encourage these options, in part because they think that there are losing funding and reputation associated with potential patent. Additionally, for a researcher, it takes quite a large effort time to share your design. He says that in the repository of the CERN 08WR, and you don't get recognition when applying for funding project etc., as you will get with a patent in your CV. How does CERN deal with this situation? Are there ways to encourage this sharing philosophy in researchers and recognize this effort without putting them in disadvantage? And he is completely agree with you statement. Patenting itself is not the goal.
No, I'm not sure I 100% understand the question, but I think indeed, so when it's about what is the best dissemination policy, right? So whenever there is an expert who has this idea about his software, for example, so what do we do? So first of all, we start with this, what I said is due diligence, where we are going to have a discussion with him to understand, okay, where are the components coming from? How did you get it? Are you using any other software pieces? Under which license conditions are they? So that already determines the options there are, as you could see from this scheme. So depending on the context, that gives us more or less options to do. And then some experts also have a very strong own opinion. They say, I want this to be open source. You know, and then of course we need to see, well, does this make sense to make it open source? Because when you make something open source, it also comes with obligations that you need to make all the documentation properly, that you need to make a website, that you need to make sure that you find the right open source license. So experts need to realize that making something open source, if you want to do it properly, also is time consuming and takes quite some effort. And then if, as I said, patenting, we don't see that so much with software, but with hardware. If experts want to file a patent on hardware, we always start to ask the question, why do you want a patent? And honestly, often there is a bit of feel, right? Well, if there is a patent, then it means my technology and my invention is very good, right? They see it as a sort of a recognition of the work that they've done. And we really always try to have the open discussion with them that for CERN, we don't want that is a driver to make that decision, because otherwise you end up with hundreds of patents that cost a lot of public money and that don't all, let's say, pay off in the sense that they don't all contribute to disseminating the know-how per definition. So we are very careful in making this decision. We will always do that in consultation with the experts and looking to what is the market, what are the costs, what is the potential to use in different domains. And then we take a decision what kind of open source license or patent strategy we use. And by the way, often the conclusion is, okay, we're not going to make it open source, we're not going to patent it, we just publish it. That's also something that, of course, can be an outcome of such a discussion. Just publish your results. So that's also, there's nothing wrong with that in some cases.
Yeah, very interesting point of view. Just the last question, because there are no time for more questions, is from Asensio and asks about how CERN gets interest in industry about CERN products.
Is it about how we get industry interested?
Yeah,
that's a very interesting question.
Yeah.
And I have well, I have to think how I can explain that without going over time too much. But I tell you, so I'm coming from industry. You know, I worked in industry for 25 years. And when I came at CERN, what I was really interesting to see is that CERN, a lot of things at CERN are technology centric, as you can imagine. But then when you want to engage with industry, and imagine that you have invented something, invented a certain sensor. Then you can go with a sensor door to door in each company, say who is interested in the sensor. But the chance that you will find somebody who is interested in your technology exactly at that time, that the company has money for it exactly at that time, and that you spoke to the right person exactly at that time, that chance is very small. So what we have done the last couple of years, we've turned it around. We go to industry, and especially industry who have a very strong, let's say, open innovation mindset, who have a long-term horizon, who invest a lot of money in R&D, who participate in European Horizon programs, and we ask them, what is the technology that you need for your innovation ambitions the next 5 to 10 years? And then we have a strategic dialogue with, for example, the chief technology officer or a director R&D, and that person then tells us that it's important for the company to invest into know-how that relates to, for example, data processing. And then when we really understand what the needs are of that company in order to make their innovation accelerate, we as a team, we're going to look at CERN and say, wait a second, what do we have that could help them? So we have turned it around. And I think that works well. It is an intensive process because it needs a company also to be willing to share where their, let's say, where their needs are. So often we first sign a non-disclosure agreement with a company in order for them to feel comfortable in sharing their technical challenges and their technical problems that they foresee the next years. And under this non-disclosure agreement, we try to define as precise as possible what the problem areas are. So let's say if you work with an automotive company, the problem area could be that it is you need more and more sensor data to be processed by a car, but you don't have the place to put a huge computer there. How can you do this in an efficient way, for example? So based on these challenges that are defined and owned by the business, we then turn around and say, what do we have at CERN to make that work? And that is really a different approach than trying to push technology out. So that's really a recommendation that I think I would have. Of course, we also have our portfolio of technologies, and of course, we also do a lot of that. But in addition, we have added this, let's say, more business-driven approach, and I think that works well.
Thank you very much for your answer, Han. I'm sorry to say that there are no time for more questions, but
That's
the
no
question
problem.
without answer, of if anybody has more questions, please send them to us by email or chat, and I will forward them to Mr. Han. Now is time to move on to the next speaker.
Okay, thank you very much.
Han.
Like with your conference.
Thank you.
Bye-bye.